Hey guys, I'm Hero Serrano and thank you for joining me once again. Uh, I hope you guys are doing fine today. Let's see. This has been a long weekend. Actually, been working a lot on the engine, and I actually was hoping and planning to stream all of the development that I did during the week. However, on Monday I did a Twitch, and it didn't go that well. So I decided to take some time to actually see what I did right and what I did wrong during the stream. So um, it took me a couple of days to kind of figure out what should I change and what should I not change. Uh, so aside from that, not much has had happened actually. Been working a lot on the engine, like I said, till like late in the morning. And I want to do a stream today, actually show you the updates and keep showing you everything else that I plan to do for today. So if you follow my previous streams, um, you can would know what I'm working on right now. Basically, what I'm working on is implementing a new feature, a new way of how to make a 3D game character go up a slope and down a slope. And I already did that in my previous on Sunday. It worked, and let me show you so you actually get an idea of what I'm talking about. So I did a small video here, which I posted on my Instagram account, and it shows the character go up and down the little mountain there, right? So the whole idea of the implementation works. However, the current implementation that I have right now is very inefficient, and I'm gonna explain to you why. All right, so let me stop the video so I can show you what I'm talking about. All right, so I'm gonna bring up Blender, which is the tool that I use to do all the modeling. How the whole implementation works, the whole idea works is that, let's say you have a character, your astronaut here, and the character is about to go up a slope, right? Um, what I do is I simply shoot a ray from the center of the character downwards, and I do a test between the ray and the triangles that make up the, in this case, the terrain. And if the ray hit the triangle, what I do is I retrieve the normal vector of that particular face or triangle. So in this case, the normal vector of the triangle is going upwards, and I use that normal vector to basically orient the character properly. Whenever the astronaut is about to approach this section of the terrain, again I shoot a ray, which will intercept this phase, this polygon, and I again get I calculate the normal of that particular triangle, and I use this normal vector and the direction of the characters to basically orient the character how it should be oriented. In that way, it will create the whole illusion that it's going upwards. All right, so that's how I'm doing it. I do not know how they do it in other engines, but this is how I think this is how they probably do it also. Now, the only problem that I have with the implementation that I currently did is that let me see. Hold on, where are you at? Where are you at? Give me 1 second. It's this one. All right. And what I'm going to do, so you can actually get a better idea, is I'm going to hide most of this, guys. All right. So the video that you saw showed you that the character went up, up this this whole mount, this hill, right? However, I'm sorry, take that back. When I do that test in the video that you show, one of the things that I do is that I do the test between the ray that I'm shooting down from the position of the character all the way to the terrain, and I do the test with every single of these triangles, all right, every single one of them. And obviously that is very inefficient. I should not be doing that. I should come up with a smarter way to do a search so that I can find the intersection between the ray and the triangle as fast as possible. As a matter of fact, this terrain here, it has over how many faces? It has 2,202 triangles. In a normal game that would be overkill. Like, I should not be doing that. So my idea is that, well, why don't I divide this whole terrain or model into a quad, right? And what I do is, first of all, I use the whole I create an axis aligned boundary box around the whole terrain, right? That basically it will bound the whole model, right? What I do then is that I divide this whole cube into 8 smaller cubes, which is what I want to show you here. And here's like one section of this, right? So I divide this this whole cube into smaller ones. So here's one of them, and imagine I will also compute 4 more of this, 7 more of this, for a total of 8. Then I go even further. Then I divide this even more, and which will be this one, right? And then I go even further, which will be this one right here. So when I do a search between a ray and a triangle, the first thing that I do is I do a search between the ray and the cubes, the in this case the AABB boxes, and why would that happen? That will reduce the number of searches that I have to do. It will eventually reduce the amount of search to only a very specific number of triangles that I have to search for. For example, instead of 2,000 that I had here, I should probably only have to do about 10 searches now between the triangles. So that's obviously, as you can tell, that is a way better way to do a search and to do the whole implementation. And that's what I did the whole week. Okay, what I did is I implemented a test between an array and an ABB box, and I also implemented a test intersection test between a box and a triangle, one of the triangles. All right. Now what I want to do today is basically implement the whole arc tree that I have, which I'm almost done with this one actually, but it's not complete. I'm in the initial stages, where I build the arc tree, and then the next part that I have to do is basically, let me hide this so you can actually see it better. The next thing that I have to do is, for every leaf in the arc tree, I need to test which triangle of the from the terrain in this case belongs to the particular cube, to the particular arc tree. Okay, so actually it would be a good idea if I bring up something so you can actually see it. Let me see if I have something here. Let me put my artistic skills to the test. Is this working? Okay, cool. All right, so imagine that right, my idea is I want to divide the whole cube into smaller cubes, right, into the whole 8 of those. You get the idea, right? So I'm going to have a root node, and then I'm going to have 8 of this, and then I'm going to go even further and divide the child node into 8 more of this, right? And now eventually I'm going to get to the point where I have, you know, a very small number of triangles within a cube, right? Let's say I have like a bunch of these triangles here interconnected. So at the end, what I need to do, I need to store these triangles into an array that belongs to the node. All right. So let's say I go even deeper here. Now imagine that this guy is actually a leaf node of the octree, and this guy right here will eventually have a vector container containing a pointer to all of the triangles that make up the whole terrain. All right. So what I have right now is I built the octree. The whole tree is already built. Now I needed to basically get a pointer to my terrain and do a test to make sure or to decide if the triangles belong to a particular leaf node or not. And that's where I'm at right now, and so that's what we're going to be working on today. All right, so let me close this down because I don't need it. Okay, let me bring up Xcode. All right, so I was doing basically all of this is being managed by this by this class called U4D Mesh Octree Manager, and this class is basically in charge of building the octree. And when I come here, the method here, I basically create my root node. I provide my initial parameters to build my cube, my AAB box cube, and then from that point on, I'm sorry, I start building the whole node, and I'm going to remove this because this is only a test that I was doing, so it's nothing that we need. All right. So this is the section of the code that basically builds the whole tree, build octree node. I basically get the center of the box, and I and the half width, and I keep dividing it over and over and over until I get my whole cube. Now, how deep does it go? Well, I have it set it to 1 for now. So basically, I build my root node, my parent node, and then I build one more subdivision, which will build basically what we have right here. So I have your parent node here. Oh, come on, parent, and then I build these 4 little childs here that you see here, 8 of those. Right. If I change this to 2, well, then that will, you know, further divide the whole tree, and it will make basically 73 nodes. If I go to if I set it to 3, it's going to create 585 nodes. For now, I only set it to 1 because I think that is enough for now to do the test. All right. So I'm gonna keep this think I'm gonna need it later on, so I don't want to remove it. All right. So before we get coding, what have I done? I implemented a triangle versus AAB bags, which I explained to you earlier. I also, this implementing rendering race, I do not know if I'm going to do that, so I'm going to delete that task. Build that tree, I already done that. This one was something I'm not going to do, so I have that. Now what I need to do is to determine if the triangle belongs to a particular, in this case not cell, but a cube. All right, so my first step is that this, okay, so I need to get a pointer to my 3D model. Once I get a pointer to my 3D model, I need to calculate the maximum dimension of the model. And I need to get the maximum dimension because I need to build a cube around it. So I need to make sure that I bound that whole model. And obviously if you use the maximum dimension, either from X, Y, or Z direction, that will make sure that the whole model is actually within the cube. Once I have calculated the maximum dimension of the model, that will basically, I also need get the position of the 3D model. All right. Get that. Then this will be for the half width. Now this one is to get the position for the 3D model, and I got that. And once I have the pointer to the model, I can also get the pointer to all of the polygons, to all of the meshes that make up the model. So get pointer to mesh that make up the model. Actually, I don't think that would be a good idea to do it here, because here I'm just building my tree, and I think it would be a better idea if I wait for my whole tree to be built, and after that do the test only with the leaf nodes. So yeah, let me not do that. All right, so I'm going to get the include before the model. I don't know if that would be a good idea, but let's just do that. View model. No. All right. I don't like that name. There you go. Fruity model. That way I know what it is. All right. So why don't we do it here? As part of my constructor, I probably should get the pointer to my model. That would be better. Actually, let me make sure that I'm using the correct naming conventions. I hate when I have to change my convention, so let me just make sure that I'm using it correctly. Oh, I am using model all over else, everywhere else. All right. View model. All right, so I have that there. And I'm gonna put it here too, so that way all right. So I have a pointer to my model. I get that. Now I need to get dimensions. I don't know what. I don't know if I should get it here though. All right, heck. Include u for the vector 3n.h. I think it would be a good idea if I actually store all of this here, have a vector 3n and model dimensions. All right, vector 3n model position dimension here. All right, so I think it would be a good idea to get all of this information in my constructor. So model dimension would be u model get dimensions, get dimensions. All right, this is where you need to use the API. All right, let me go to get the API. Get model dimension. There you go. So model get model dimension. Boom. Now this one is gonna give me a little bit of problems later on, I know it, but I'm gonna just get absolute position. What do you mean? I'm forgetting something then. Get model dimension. We're not getting it. no member name get model dimension in U4D engine U4D model. What do you mean? Things gonna build now. Am I getting the same error? What do you mean, dude? It should be there. Don't tell me I have this somewhere else. Alright, so according to here, I should be getting this. I mean, U4D 3D model, U4D model, get model dimension, vertex, boom, U4D model. Okay. Why are you giving me that error? Did I forget something? Did I forget something? What went? It's a semantic issue that I'm having. Okay. That's right. Okay, for now, dude, I'm just get rid of that stuff. I don't need that. Alright. So, I think that fixed it. Don't ask me what happened. Okay, what in the world is going on then? My model has that method. Hold on a second. Hold on. Are you saying that this probably okay, let me go back to my here and let me see where I have it here. because it is probably part of something else. Oh, okay, part of the static. God damn it! All right, that's the problem then. Well, okay. What should I do? Should I do here? Should I make it dynamic or static? Oh, well, the only difference between dynamic and the static model is that the dynamic can make use of the physics engine. The static does not, but it makes use of the static of the collision system. Now, well, since everything here basically needs to be part of a game object, I'm just gonna make this dynamic. That is the problem that I'm having. Dynamic model, which makes me kind of weird because this should not be. Oh, that's why I didn't get it. Get model. I need to change that. Okay, now this would actually would have told me that it's for the static model, not for U4D model. Okay, now that is what is going on. So I changed that to dynamic. This one is going to be dynamic now. And I'm going to change this also to dynamic. Alright, let me change this. I don't need this right now. And that should actually fix all this. So I was supposed to go play soccer today. Still have a game, but unfortunately my foot hurts and it's not good. Yep, I meant that one. All right. Okay, so I have the dimensions and I have the position of my character. Okay, now. All right. What else should I do now? I also need a pointer to all of the polygons making up my character. But before I do that, let me actually just get this. So from the build tree, why don't we compute the maximum half width for that? Okay, so compute maximum half width for the box, and then get the center, well, I have the position, so that shouldn't even matter. All right, so model position is a vector. So float max half width. So why don't we do something like this? Standard, maximum, right, between the model position dot x and model position dot y, and I do another one of this actually. and then the model that between the model position, that is Z. All right, that should give me that. And I need to divide that by 2 because it's that this one is giving me the whole dimension. For example, in the X dimension, it's going to give me the whole dimension. I only need half of it because that's the half width of the cube. So max half width divided by 2. All right, and then underneath this, and I'm just gonna move this here, and then the center of the cube, center of AABB, will basically be my model position at that point. Model position to vector point. Now you see here I did a mistake. I was actually computing the model position. No, it's the model dimensions that I need to get, not the model positions. All right, so that should be divided by 2. Then I get my new my root node. I create a new root node, and then this one's going to be center of my box, and this is going to be my max half width. All right, and 1. Now what I'm going to do, I'm going to do a little I'm going to create a small 3D model. So we can actually double check, test if this actually is creating the whole Octree with the proper dimensions. All right, if I build this, it should be fine. All right. So new. Yes. Let me delete this, and I'm simply going to do a small plane here. And dimensions. The dimensions are these ones, 220. All right. So whatever box, whatever cube we create has to be at least has to be the half width has to be 1, which will encompass bound the whole plane. All right. So that's all what I want. Plane. All right. I don't think I have my. So let me export this now. I'm going to run the exporter that I wrote. Run the script. And boom, boom, resources. And yeah, let me just put it here. It's for the heck of it. All right. So now I'm gonna go to model, to earth here, and I want to create my astronaut. All right. So new U for the game object. If my astronaut load model, and here I'm going to give the name of the model here that we did it, and it was the name of this plane is actually plane, so we need to give that name. And if I'm not mistaken, I exported this in astronaut attributes. All right, that's the file that I used to export the data. Let me cancel this. So should be that one. Astronaut attributes.u4d. Let me double check. If I open this, I should have my plane here, which all of the data, perfect. And the dimensions, which is shown here, and the position, which is part of the local matrix here. All right, so we're good. Now, if all of this goes fine, what's the method? And if you ever want to, use the engine, I wrote a whole documentation here that you can refer to whenever you're creating a character. So here I'm basically rendering a 3D model, and I honestly forgot the method name, and that's why I needed to look for it. Load rendering information. All right, and after I have that done, add a child and my astronaut. All right, so after I do that, in here what I'm going to do is I'm going to create U4D Mesh Org3 Manager. And I know you may be thinking, hey, this doesn't look clean. I know, but I'm testing everything out. Later on, once I know that everything works, then I'll come back and I clean the whole API, so it looks a lot better. My astronaut. Basically, remember that here I need to give a pointer to my Org3 manager. If you recall, in my constructor, I'm requesting a pointer to the 3D model. All right, and once I have, I'm so sorry. Hold up. Am I going to create a new here then, or what? Do I want to do it like that? Alright, let's do it like that. U4D Mesh Org3 Manager P, and I'm gonna give it my astronaut pointer, and then I'm gonna say P build the Org3. Boom. Alright, that's what I'm gonna do there. And I don't want to render anything right now, I just want to do a test. So once it builds the Org3, it's going to come here, it's going to do that build Org3, and it's going to basically go through the whole process. And what I'm going to do, I'm just going to make sure that the whole dimensions for the 3 actually are properly calculated. All right, so this is just test, and I'm gonna stop it here. All right, so to recap, we created a model which is of dimension 2. All right, it has 2 triangles right now. All right, and let's see what we get. All right, so we got what I did. I basically printed all of the center, the midpoint, the minimum point, and the maximum point of the AABB into this window right here, so that way I can actually test if everything works. All right, so let's go to Blender. And I'm gonna save this plane test arc3. So I don't want to lose that. Arc3 test. All right, so here's my Arc3 test, right? My okay. Now all of this here that you see here are actually the cubes that were computed, all right? So the first one is actually my parent, and then the other ones are actually the smaller cubes that are coming in. So we're gonna test this. Let's see. Let's see how I can actually set this up so it looks good. Okay, the first one, which is my parent. Is this one, all right? So it says that the center is 0, which is good, and then we need to get the minimum and the maximum point. So the minimum is -1, 1, 1, -1, -1, -1, and my maximum is these points right here that you see here that I'm highlighting. So it's 1, 1, 1. So that's okay. Then the first child of this cube would be this one, and let's see, the center for that is incorrect. Oh, sorry, I was looking at something else. So the center is basically at 0.5, 0.5, 0.5, and that is what I get here. And now my minimum point is 0, 0, 0, which is what I have there, and my maximum point should be 1, 1, 1. So that one is correct. Now let's do the second child. I think I can work with that. So the second child, my center is -0.5, 0.5, 0.5, and my minimum is -1, 0, 0, and my maximum is 0, 1, 1. So that's okay. All right. Now third. Okay, the center for the third one is 0.5, -5, 5, 5, -5, 5, and my minimum is 0, -1, 0, and my maximum is 1, 0, 1. Now you may be wondering, why am I saying that they are correct when you can, for example, here for the maximum point for this particular cube is 101 according to the engine, but when I test it on Blender, it shows 110. Well, the issue here is that Blender uses a different coordinate system than what the Metal API from Apple uses. So they actually reverse the Y is X and the X is Y. So that's why I'm testing it that way. All right, so that's the third one. My fourth one is this one, and the center is -5, -5, 5, And let's do this really quick. -1, -1, 0, 0, 1. All right, that's good. Now number 5. My center is 0.5, 0.5, that's right. Minimum, that's correct. Maximum, that's correct. All right. Okay, a few more to go. 6. 6 is 5.5, that's correct. And my minimum point is -1, 0, -1, and my maximum is 0, 1, 0. All right. Next, the seventh cube. -0.5, -0.5, -0.5. All right, that's good. And the last one, let's just make sure this works. And you need to do both, bunch of these tests, because you really do not want to move forward and realize that the whole structure of the octree is completely messed up, or else you're going to be wasting a lot of your time doing all of this. All right, so here, -5, -5, -5, and my midpoint will be -1. Right, and my maximum 0. Boom, perfect. All right, so what I'm going to do now, I'm going to get all of these guys, and I'm going to put it here. All right, so that way we can actually see that how everything works. All right, so now that I have the octree basically surrounding, like bounding the plane, that the next thing that I need to do is determine, right, how many cubes did I bring? Oh, I only brought, holy cow, hold on, I only brought 2 cubes. God damn it, I didn't copy all of every single cube because they were not visible at that time. There you go. All right, so boom. All right, that's what I want. I have all of this. Okay, now we know this works now. We're good. Now let's retrieve the faces that make up the model and do a test between the triangles and the leaf nodes from the octree here. If they do belong to the octree, then we store them in the vector. If they do not, then we ignore them. All right. Now from the look of it, it's going to show that all of every octree here actually intersects with a triangle, which is true, right? So in our test we should get that every single one of them actually has a pointer to the particular face of the plane. So this leaf here should have a pointer to this guy, but this leaf here, right, this one, it intersects 2 different planes. So come on, dude. So we should have basically two pointers to the triangles. All right, Okay, let's do this. Let's do this. Let's do this. So now that I built it, what should I do? I do not want to do that test while I'm building that oak tree. That's gonna be kind of, although it is possible, I feel that it's not gonna be as clean if ever need to come back and debug the whole engine. So what I'm gonna do is I'm gonna create a new method here, void, and let's call it assign faces to node. I like that node name. Right, so basically that's going to assign the faces of the model to the node leaves. All right. So for every node leaf that we have in our tree, it's gonna do the test. I like that stuff. I love it. All right, let's put it here. By the way, this is, I think, my 7th or 8th time I go on Twitch. So if I'm not doing good, forgive me. For now, I will get better with time. But my first time that I went live, believe me, I was very, very, very nervous. So if you're thinking of doing the same thing, it's fun. Okay, after you do your first Twitch, it's kind of I don't know how to, you feel kind of type of a high, right? Like it's a rush that you feel excited after you finish the first your first Twitch. But before that, like anything else, I was very, very, very nervous. But then I kept doing it, and actually my second time it was a total disaster. Then my third time it was okay. The one that I did on Monday was a total disaster. So you know, I'm that type of person that I'm okay doing experimenting something new and figuring out if it works or if it doesn't work. You know, if something doesn't work, I just don't like to stop it. I'm like, okay, well, that doesn't work, well, let's do something else. Like, let's change gears here. Probably I should do it this other way. Basically, like, you never fail, right? You only like learn. Like, you learn from your mistakes. You only fail if you give up and you don't do it ever again. All right, so it's okay, right? If you fail, well, you learn something, and that's the whole point of it. Like, I can actually share my experiences, you know, up to now. Like, how has it been for a new streamer to go live, and you know, what should I do differently? And I'm still learning, right? But I have an idea right now what works and what doesn't work, which is something that I didn't know when I started. And that's why I like the phrase that says, you do not know what you do not know. So, like, for example, you may have an idea for your business, right? And you say, oh, I'm going to do it like this, I'm going to do that, and on and on. Well, here's the thing. If you go into a business without the mentality, you know, that it is okay for me to fail, it is okay for me not to reach my goals, as long as I keep moving forward, then you're going to succeed, right? Because you do not know what you don't know, and the whole point is about learning as you go. All right, so let's go back to my engine. Assign faces to the node leaf. Well, here we need to get pointer to the faces composing the model, and I hope I wrote that method. Okay, once I get that pointer to the faces, test into do an intersection test, right? For each leaf, test which triangles intersect with its ABB box and store it in a vector container. All right. Is that all that I have to do there? So I go through my each node of my octree, and I do a test which the triangles composing my model, and I store not that triangle itself, not the whole class of the triangle, but just hold on. Let me see how I have it stored here, because this is something that I implemented 2 weeks ago. So the class that actually contains all of that data is this class for the polygon data, and I know that I store all of those the faces into this container called faces container. Okay, and now I do get a vector. I can get a vector containing that. Oh, okay. So instead of storing the whole triangle in my container, I can just store the index number in the vector container referring to that particular triangle or a face. So that way I can save up on, I can save a space. Add a vertex container, add a face container to this. Alright, I think I can do that. So now in my octree node, man, I need to document this. I can do a vector include vector. So here vector, I can just do int. So let's see, triangle index container. I think that will actually save me a lot of memory. Alright, let's see how this is gonna get. Get pointer to the face composing the model. So here we need to get vector. Vector. And if I'm not mistaken, this gives me is for a triangle. Base container equals model get. Hold on. Let me go get it. Get faces data from container. Alright. However, I need to call it this way. Polygon information. All right. So model that is model, right? All right, model, polygon. That get faces data from container. All right. All right, so I get a faces data from container. What's going on here? No viable conversion from STD for the triangles to what? Oh. All right. All right. So here I'm just gonna copy this because it's basically what I need. I'm gonna go through this whole code right here right now, so you can actually see what I'm doing. So basically, the first thing that I do, I get my root node, right, and assign it to be as my child. And then in a while loop, basically, I go through the whole root, through the whole tree, and basically doing I basically traverse the whole tree, doing this while loop. While child is not it's not a null pointer, and if the child is not a root, because I don't want the root, I want the parent and all of the children, the parent and all of the children that compose the whole of tree. So if it's not a root, do nothing here, right? Else here, what I'm going to do, I also do not want to do the test on the parent. I want to do the test on the actual leaf nodes, right? So else if is leaf node. So if you're the leaf node, then I want you to do the test. So I'm gonna put it here. So here would be traverse the tree. Now something that I'm gonna share with you, if you're planning to do this sometimes, go live for the first time, is that I don't know about you, but having the feeling that somebody else is watching you as you're coding, it puts a pressure on you. It puts a pressure on me, to be honest with you, and I kind of tend to have these moments where my mind goes blank, totally blank. All right, like for example, my first couple of Twitch that I did, I could not remember several of the API functions that I myself had wrote for the engine. I think there was an occasion where I literally could not remember how to write a very simple code snippet that I have, something so simple to do, and I just couldn't remember how to do it. And luckily I had written all of this in the documentation here, so I had this as a backup to come back here and actually check it. It's something that I still need to work on, because I think that the pressure or the feeling that somebody else is watching you it puts me on the spot, and it makes me a little bit nervous. As a matter of fact, if you notice, I had to come and open up this document because I forgot the name for this function, like load rendering information. So keep that in mind if you ever want to go do this live. I hope I will be able to get rid of that fear. I don't know. Well, I wouldn't call it fear, but that feeling of being unease when somebody else is watching you. Okay, for each leaf, test which triangles intersect with its AAB box and store it in a vector container. All right, so I know each leaf here has an ABB box, right? So which the AABB box acts as a line, does the bool intersection with a triangle here. All right, so why don't we get the ABB for the leaf, all right, and then do intersection test between AABB and triangle and face container. All right, so child ABB volume that intersect with a triangle. Yep, that's what I want. All right. Basically, I had written that already. For auto and in face container. All right. Alright, but I know that this intersect test actually returns true if there's intersection, or false if it's not. Alright, so I need to put this inside over here actually. So now once I reach a leaf node, right, I do a test, okay, for each triangle in the face container that I got from my polygon information. I'm going to do the test with the leaf AAB box, right? So here is what I do for for each of those triangles. I'm going to do a test. Okay, now if the test results as does find an intersection with a triangle, then what I need to do, I need to add that that index. Oh, then I shouldn't do it like this. I need to get that index into that. So instead of using it like this, which I kind of like, but I'm not gonna do it right now, in I equals 0, I plus plus, hold on, I is less than face container that size, I plus plus. Here I'm gonna make a triangle basically. Face equals face container that adds I. All right. Face and So if that actually, if there's an intersection, then I'm gonna do child that was my container for the triangle index container. Push. Store index. Oh my gosh. All right, let's see. Let's take a little break. A break from what? There's a lot of work to be done. Okay, let me go over this code really quick, and then I think I'm gonna take a little break. So once I reach up the leaf, right, I basically do a search through the whole face container vector, and for each triangle that I find, I do a test with my box, with the bounding box, and if there's an intersection, I basically store the container. I store the index number, right? So so that way I can refer it back later on. I do not want to store a triangle because that would be kind of stupid to be storing, the triangle in another class. So I just store the index, which I can refer to later on. All right. But like when that happens, then how am I going to retrieve that later on? Okay, we'll think about that when we get there. All right, but I think this should work. Alright, so after I build my tree, right, then here I assign the triangles to each leaf node. Assign the triangles faces of polygon. That's how I should refer it. Right? Cool. Now let's do the test here once again. So on Tuesday I went to play soccer, and for some reason within 5 minutes of playing I felt a sharp pain right at the ball of my foot. And I had to basically, I didn't play well that day because of that pain. But after that day, I have not been able to walk properly, and I was hoping that for the pain to actually stop, but it hasn't. So I have a game like within an hour and a half, but actually I don't think I'm gonna go because I don't think I will be able to play for 90 minutes like this. So I may just go to the gym and like ride up the bike or something. That way I don't put too much pressure on my foot. Hold on, give me 1 second. It's getting kind of hot in here. So. Alright. So that is that. Okay, let's take a little break here. Let's see if you have some questions for me. Like for example, one question that I get a lot is how long does it take to build a game engine? And I have given my answer on different social media platforms, but essentially per my experience, it's going to take you about 5 years to develop a game engine, like completely from scratch. And the hardest component to develop is the collision detection. The physics engine is not hard. Uh, it's hard to, I wouldn't call it hard. It's just you really need to understand your mechanics, like Newtonian physics, uh, properly, very well. So if when you were in high school or college, you were good with physics, you understood the Newtonian mechanics quite well, then developing the physics engine is not hard at all. It really is not hard at all, because all what you need to really, the main thing that you need to worry about is um, integrating the equation of motions. That's about it. The rendering engine is not hard at all, but it's confusing. Right? That's the confuse. That one is confusing. The collision engine. That is. It's not confusing. All right, because the whole idea is very simple. But it's really really hard to develop a collision detection system. As a matter of fact, the collision detection system in the engine, it's, I would call it okay. It has several flaws that I'm planning to fix in the future. Um, but man, honestly, I think I would have to, like, I it would take me one more year to make it very robust, super super robust. So, you know, till the day comes, what I have right now is okay for simple games, small games. So it should be okay. I was also checking out HIO, and I'm actually thinking of let me bring it up. Where are you at? Here. I'm actually thinking of putting the engine here on HIO. I think would be cool, because this is basically where most indie game developers submit their games, and this is where they usually also look for tools. So I decided to. I'm not decided. I'm in the process of deciding whether to put it there or not. What I did actually last night, I created a page to see how everything looks. Uh, but from what I can tell, I think I'm gonna put the engine here. And what I like about this is actually that I can have devlogs. That's what I like a lot about this. I can actually put my devlogs here, my release notes. Because what I have right now in the when you go to Untold Engine, what I have here, I have my release notes in one page, and I think it's okay. But I think bringing it over to H would be will help. So that's what I think I'm gonna do this weekend. Alright guys, let's go back to the code. Let's see how everything is actually working. And I've been live, how long? An hour and a half. God, wow. Alright. Okay, so leave node. Not leave, just leave like that. Alright, so for this guy, for each of those, oh my god, okay, what I need to see is if the number of what I need to check is what is contained in this vector triangle index container. What do they have here? How many triangles do they have? All right. Actually have removed this one because I want to get a center, so that way it can give me a sense of which I'm referring to. All right. So this is leaf. That's the center, and now I want to child. I just want to get a count, that's all. Child size. That's not what I really want. So see out std_nl. Yep, that's it. That's all what I want. I want to see the number of triangles that they have in it. Some of them, if we look at Blender here, some of them should only have. Hold on, how can I make this cooler? Okay, I know what to do. So for example, my parent here should have access to 2, right? To 2 of these triangles, but I don't care about the parent. What I care is about my node, the leaf node. So the first one that I'm going to get will be this one, and this guy should have access to only 1, right? Because that's the only one that is colliding. Not, so I hope it's not going to get this one also, but this one should only get 1, right? All right. So let's see. We're gonna do a bunch of tests, which may be boring, but they are crucial to do. Test this. Let's test this. Sweet. Now let me just let me bring this over here, so that way it's a lot easier to double check. Let me get Sublime. All right, leaf 0. My leaf 0 is at the center. Uh-oh. I see a problem already. One, two, three, 4, 5, 6, 7, 8. How many do I have here? Oh, okay. I'm sorry, guys. Here, leave else if child. We need to only test that if it's a leaf. From what I got earlier, I was also getting the parent, and I don't want the parent. I want only the leaf nodes. That's all what I want. All right. So, boom, boom, bada, boom, bada. Oh man, and from what I can tell, I'm actually getting it now what I want. All right, so the first one is actually centered at 0.5, and it is saying that, guess what, it is saying that it is actually um, intersecting with both of these guys, both triangles, which is not what I want. And all of them are doing the same thing. See, all of them are coming out with the same count. So I'm wondering if what it is that since they are very close to this edge right here, it is also saying, hey, this when it does the intersection test, it thinks that it also belongs to that one. Oh man, let me see if I can do something here. Alright, I think I have an idea. Let me delete this plane and I'm gonna create a new one. Let me put it back to 0, 0, 0. Alright. Now for this plane, what I'm gonna do, let me hide this cube. For this plane, I'm going to all right, and put it there. Alright, so if I triangulate this, I'm gonna get a bunch of that. Alright, so my cube here, if I get this cube, I should only get 2 and not 4. Okay, so if that works, then we're good. Alright, so let's do it again. Let's do that again. Okay, yes, I think this works. This worked. I'm not completely happy though, to be honest with you. Alright, so the leaf that is in at the center, point 0.5 has only contains two of the triangles, which is what I want. All right, now let me check the next one. Now this guy right here is at negative 0.5, 0.5, 0.5, which is this one, and this guy supposedly there you go, contains all 4 triangles, which is this one, this one. This is the count of the triangles that I'm getting. So it basically intersects with 4 faces from the plane. So which is this one, 2, 3, 4. Yep. Okay, that's good. Now let me do the next one. This one should only intersect with 2. Alright, so that one is negative 0.5, negative 5, so this one is this one. It has 2 triangles that are intercepting with. Alright, let's go to the next one. Negative 0.5, negative 0.5, and 5. And this one, according to this, has 4. And yes, that is 4. That's correct. That should be 4 right there. Alright. What's the next one then? 0.5. This one. Holy shoot! Looks big. Looks huge. My center is 0.5, 0.5, -5. 0.5, 0.5, -5. And this one has 2, which, okay, let me double check here. Dude, come on. Yep, 2. Alright. Now the next one should have 4. -0.5, 0.5, -5, and no, according to this one should have 3. Alright, let's see. Oh yes, that's right, it has 3 actually only, not 4. Okay, alright, that's cool. Then the next one, leave 6, should have 2, which is correct, right? -0.5, -0.5, okay, and then the final one, which is this one, that one should have 3 also. Alright, yep. So they're all of them, they all work. Perfect. Perfecto. We are good now with that one. Alright. So this little test that we did, this implementation actually works. Alright, so when we assign the faces, it's actually assigning the whole faces to the proper cube. Alright, okay, we are doing good. Okay. Now what else do I want to do? Okay, so I assigned the faces to the model leaf, right? So now we're good from that point on. Because later what I can do is that when I want to do a test, I basically can call this particular object manager, and I can get a hold of my root node, and I can traverse all of the children in the tree and do a test between array and the children in the tree. So it's going to be the array and a cube test. All right. But where else should I actually put? See, what I'm thinking is that when I'm actually doing a game, right? When I want to make and I want to test if my character is you know, is hitting it's about to go up a slope. I need to shoot an array and check for intersection with a particular face of the terrain, for example, right? How do I go about doing that in the sense of, do I make the game developer code this class, no, the class here, which is the U4T Mesh Tree Manager, right? Or what I do is make it easier for them to simply do like get a pointer of the root node that this class contains, which is this one. And once I have you have the root node, right? You can use the root node to have access to your tree, and you can basically just provide array to that one. I have to think about this. I have to think of how I'm gonna make it easier for the game developer to use this class. Like for example, let me see if I can actually put my thoughts into in writing. So hopefully this can help actually. So for example, the first thing that you do is you create a 3D model, right? There's your model right there. Boom, whatever. Now what you want to do is you want to assemble all of the faces of this model, right, in a nice way so you can access it later. And when you do that, you would actually do code the mesh manager. And the mesh manager will create a whole tree, oak tree, right, with the faces and on, right? This is my root node. Then during the whole gameplay, right, you may want to do a test between the array. Here's array of, let me put it like this. So let's assume this is your character and you shoot a array downwards, and this is your terrain right here. Right. You're having the game, the characters are moving, then you shoot the array. So I think it would be a good idea to do another class. For example, let's call this array cast, right? That basically gets a pointer to the array, not a pointer to the array, but as a parameter you get array, and the other parameter that we get is actually a pointer to the root node, right? So here would be root node here, and that's a pointer, which is this guy, right? And then the array cast class, what it can do, it basically does the test between the array and the ABB boxes of each of the nodes, right? And then once it has detected a collision with the AAB box, it goes all the way down to the node, right, that contains this access to the vectors of the triangles. So once it gets to this point right here, point 1, point 2, So this is test 1. Then it does test 2, which is basically all about doing the ray again and the triangle test, right? And we can have this raycast class. Basically, it would be something like this then. And I'm just thinking out loud here, right? So a raycast, and then we have a hit method here, right? And the hit method actually can return a pointer to the face. Yes, so then the hit method, what it can return is it returns this guy, my triangle, which I can later use to change the orientation of my character. So basically you create a 3D model, you do a mesh manager, and the raycast class, what it needs actually. Alright, yes. So what it needs is a pointer to my mesh manager, right? Why don't we do it like that? A pointer to my mesh manager, right, which is this guy. Now within the mesh manager, I have my access to my root node, which then I can do the whole search, and then I can return my triangle. So this returns hit face or hit triangle, whatever, and that can actually work. So I create another class called raycast. It takes as a parameter, and that class has a hit method that takes in as a parameter the ray, right, which is going to be shut down from the position of the character all the way towards, you know, whatever it needs to go. And then the other parameter is a pointer to my mesh manager, and my mesh manager contains my root node and my tree, and it can do that. All right. Well, what are the pros of doing something like that? Oh, I don't know, that may actually work. Alright guys, I'm gonna go work out right now. I'm gonna come back hopefully later. I'll send a tweet if I decide to go live in the afternoon, like around 2 p.m. If not, I will definitely be on Twitch again tomorrow morning. I think like around 8 or 9 a.m. And I will go from, I guess, from 8 to 1 p.m. or something like that. But one of my goals is to have this completed by tomorrow at least, because there are other issues that I need to fix in the engine, and you know, I want to move on. Alright guys, thank you so much for joining. I'll see you later in tonight, in the afternoon. I will send out a tweet, okay? Or definitely tomorrow morning. Thank you. I'll see you then. Bye bye.